Hi guys, I'm Tiffany from Miss Bouget's Period 3 class, and I'm going to do a problem on DC circuits to help study for the final review. So the overall question has two questions in it. One is to draw and label a circuit where such change could occur, and this question is based off of the graph they give you. And then the second question, part B, is to determine the resistance, potential difference, and the power output for each element in the series circuit. And what it means for each element is one element is for the resistor 1, which is like the B and C, and then the other element will be for D and E for resistor 2. But I'll show you that later when I draw the circuit. Okay, so this is just a closer view of the graph, and it just shows you the position on the bottom for your x-axis and the change in V on your y-axis and the intervals, and it's pretty easy to see the decrease and how it stays the same and the increase that it occurs. And then this just labels it for you. So I labeled the graph how it decreases by 25 volts from B to C and how it decreases by 75. So that's just a change in V from B to C and then from D to E. Okay, so now I just drew a picture and labeled it A through F. Actually, I missed one then. I missed F. But that's just a circuit. And then it shows you how it starts from 0 volts to 100 volts, and then A is where it begins at 100 volts. And then for the first resistor, you have B and C on each side, and then you're gonna have the same thing, D and E on the on each side for the second resistor, and then F would just be at the end next to A, where it says 0 volts. And then now we're going to go into part B, where we find the resistance, potential difference, and power output for element B and C. And element B and C was just the first one, resistor 1. Okay, so what they give to you in the problem is that the current is 2.5 A amps, and then the change of V is 25 volts, and you can find the change of V by looking at the graph, and that's where what we did in the first place. And then current equals the potential difference over the resistance. So I just plugged in what I knew for my given, which was 2.5A equals 25 volts over R, and then you just derive it for R, or you just solve for R. And then you get your resistance to equal 10 ohms. And then we solve for power, knowing the formula power equals the potential difference squared over resistance. And then I just plugged in all the numbers for that, and I got power equals 62.5 watts. Then the second part is basically you're doing the same exact thing except with different numbers, because this is for element D and E. And the only difference is that the potential difference for this was higher at 75 volts, but the current still stayed the same at 2.5 amps. Okay, so first you solve for current using the same formula. Current equals change of V over R, and then you know that 2.5 amps is current equals 75 volts over R, and then you just solve for R, and that gives you 30 ohms. And then you just use the same power formula equation to solve for power output, and that is the change of V squared over R, and you get your power to equal 187.5 watts. And that's just a clearer image of it. And then you're done. And that's just the completed page with all the solutions and questions on it. I hope this helped, and good luck studying.